Question 3. Find an estimate of the mean loam height. Now, if you had the paper in front of you, you would add a couple more columns. I'm just going to do the extra columns since I have the paper here as well. First column I would want is midpoint column. So midpoint. So we're looking for the middle of these categories here. Shorthand way of doing that is to add the two limits, the 65 and the 75, add them together and divide by 2 if it's not immediately obvious where the midpoint is. So we're going to have 70, we're going to have 77.5, we're going to have 85, 97.5 and 107.5. And then my next column is going to be midpoint times frequency. So that is 2 multiplied by 70, 7 multiplied by 77.5, and so on and so forth. So I'm looking for an estimate of the mean, and what I'm looking for is the total estimated height of the loams. So that's the sum of this column here. Divided by the total number of loams, and that's the sum of the frequency column here. So my estimate of the mean then becomes 5220 divided by 57, which is 91.58. I'm going to make sure I include units, and because I've rounded, I'm going to say how I've rounded that. It doesn't say in the question, so we just have to choose some sensible bit of rounding. For part B, the cumulative frequency curve, obviously mine is going to be a bit rough and ready because I'm not using proper graph paper or rulers, but anyway, we'll get the sort of general gist. So I'm think about this. First of all, my total frequency is 57, so I need to go up to maybe 60. So I'm going to use 5s. On the x-axis, I've got to go from 65 to 110. It seems like a waste to actually include 0 to 65, so I'm going to draw myself a little one of these zigzag breaks thing. And what 65 to 110 is 45. So yeah, I've screwed up my scale a bit here because otherwise I could do 5 per square, but I suppose we'll just have to settle for 10 per square. But obviously you would have a proper piece of graph paper, you'd be able to choose a little bit better. So we'll call this 60, 70, 80, 90, 100 and 110. Which is going to be a little bit sketchy, it's not going to be all that accurate. We better label our axes, I think. So this is going to be cumulative frequency. This is going to be height in centimetres. So the key when we're plotting these points is that we're plotting at the ends of the category always. So in the category 65 to 75, I'm plotting at 75, 75 to 80, plotting at 80. I'm going to add a column onto the question paper to save ourselves a little bit of space. That's the cumulative frequency column. And that's just a running total of the frequency. So 2 so far, add 7 gives us 9 so far, Add 21 gives us 30 so far. Add 15 gives me 45. Add 12 gives me 57 so far. It should be obviously the same as the total frequency. So I'm going to plot at 75 on the x-axis. I'm going to plot 2 on the y-axis. At 80 I'm going to plot 9, etc, etc, etc. So as I say, it's going to be very kind of rough and ready, my version. Actually I can plot one more point on here, which is at the beginning of the first category. I know I haven't accumulated anyone, so I can put that at 0. I'm going to do a really rough kind of curve between these points, but you know, as always, the key point is has to go through all of the points, and it can never appear to be going downwards because we're accumulating as we go on, so never going downwards. So yeah, we're pretty much done with the cumulative frequency. Now I need to use it to estimate the median. It says mean on this paper, but it should say median. So what I'm going to look at is, okay, I've got 57 is my total frequency. If I do 57 divided by 2, that gives me 28.5. So I'm going to read across on the y-axis at 28.5, obviously very roughly on mine. It's kind of about there-ish, I suppose. Read across, and I'm going to read down, and okay, it looks something like 88 on mine, give or take. Again, units. Now for the interquartile range, I'm going to repeat a kind of similar activity. I'm going to find the lower quartile and the upper quartile. For the lower quartile, I need to know what 57 over 4 is. So what's that, 14.25. I know what 3 lots of 3/4 of 57 is, which I guess 42.75. So these are the two values that I'm going to be reading across from on my graph. So obviously again extremely roughly on mine. So 14.25, okay, sort of nearly 15. It's going to be about, let's call it 83. For the upper quartile, I'm going to read across from 42.75. Well, I don't know. Let's call it about 103. That gives me the interquartile range is the difference between these two, which is 20 centimetres. They normally give you a little bit of leeway. Obviously your estimate is going to be much more accurate than mine because you'll be using proper graph paper. For question 4, this is a classic sort of step graph question. You notice in this example they've actually said that the beginning of each line is included because the ball there is coloured in and the end of the line isn't. So if you were on exactly 2 hours worked, you would actually be charged £30 or £30,000. So part A, 150 minutes. Obviously we've got to change that to hours because that's what our units are on the x-axis. So that's going to be 2.5 hours. So I'm just going to read up from 2.5, read across, that tells me 30. I'm going to pay close attention to the question because it does say in thousands of pounds. So the charge is actually equal to £30,000. Very reasonable. The job starts at 10:30 and finishes at 3:30. I'm going to put this into 24-hour version just so we can see that that's 5 hours. And here's where we need to read this graph properly. Up from 5 hours, that's an empty ball, so the graph isn't really there, it's up here. So 40, 50, that's 60, £60,000.